Okay, the next question posted in the group, Divan, is a solid cylinder is rolling down an inclined plane of angle theta. The coefficient of static friction between the plane and the cylinder is mu s. The condition for the cylinder not to slip. Important. Condition not to slip means that, remember, we use normally when something is rolling, we say that V is equal to R omega, or omega R if you write it as vector, and A is equal to R alpha. These are like conditions for no slipping. This will happen only if there is no slipping. So need you only have that. So whenever they say no slipping or not slip, which means you have to use this condition. This must be satisfied. Okay. So here I'm going to use A equal to R alpha because forces, torque, and all these things. So the condition is A is equal to R into alpha. This is what I have to check. So first I have to find A, then alpha, then equate and get the condition. Okay. Now, A must be equal to R alpha. Now look at this. So this is the cylinder, and it's moving down. It's force act out. It's on a wedge. So we know that. Watch the videos. So it is mg sine theta in this direction, mg cos theta in this direction, and they'll be acting at the center of mass of the object, and then friction will be acting at the point of contact. This is the friction. If it's rolling purely, this is static friction. Okay. And then upward normal will also be acting at the point of contact, will be acting through this point. So there are four forces, 3 mg have resolved into 2 components. So it is total of 4 forces, 2 along x-axis, mg sine theta, and frictional static along x-axis, normal mg cos theta along y-axis. Okay. And since there is no motion along y-axis, I can say that n from this thing is equal to mg cos theta, just like the first condition. Okay. And now, the object is rolling and moving down. This is moving down in this direction, accelerating, and it's also rolling. Acceleration, I have to use F net equal to ma. So F net is equal to ma, and it's accelerating downward. So downward force is taken as positive. So mg sine theta, and against, remember the x and y. Whenever you have a wedge problem, we normally take this as the x-axis. This is the y-axis. So along x, there are 2 forces. This is positive in the direction of acceleration. This is against the acceleration. So that is taken as negative. So minus static friction is equal to ma. Okay, from here I'll find A. Okay, so if I divide by m, I'll be getting, let's say like this. This is mg sine theta by fs by m is equal to A. Let's say this equation 2, for example, because I'm going to use it over. Next, now alpha kandupidikkanum. Alpha, obviously I'm going to use torque. So tau is equal to I alpha, torque about this point. Okay. And since I'm taking about this point, these 3 forces will not contribute any torque in R0 item. So, or theta 0. So here the torque is only due to Fs. So it is Rf sine theta is equal to I alpha. I is a cylinder, solid cylinder. So we know I is mr square by 2, and alpha. R is same. Okay. So maybe I'll use the same R, small r everywhere. R is the radius. Okay. So mr square. So r cancel. So my alpha is, what is this F? Okay. Be clear. Which force is causing this rotation? Only this Fs. So this F is static friction. So cross multiply 2 times Fs sine theta by, we can find the condition that, yeah, 2 times Fs sine theta will be equal to by m into r is equal to alpha. Is it okay? So it's alpha. Okay. So we have got alpha, we have got A. I can substitute here. That will give me the relationship between them, from which I can find F. Okay. So let's substitute that here. A is equal to R alpha. A is mg sine theta minus Fs by m is equal to R into this. So R into 2 Fs sine theta by mr. So R cancel, cancel. I'll be getting, and again remember here sine theta is 90. Okay, I cross substituted here itself. This is sine 90. You see Rf sine theta, R kum F kum angle 90, sine 90 is 1. So I don't have to write sine theta here. Even if you write, it's 1 sine 90. Okay, so this is just 2f. So when I rearrange this, this is mg sine theta is equal to 3fs. Okay, so I have found Fs. Now you see, whenever you look for these inequalities, you should quickly go and think that it is the static friction condition. Okay, that's the idea. So remember the static friction force is less than or equal to mu s into n. So whenever you have an inequality for friction problems, you have to go to static friction. I have found Fs. Fs is mg sin theta by 3. Okay, so it is mg sin theta by 3. Okay, the theta is here, this theta, less than equal to mu s n. What is n here? Mg cos theta. So this is mg cos theta. We lose mg. So rearrange tan theta is less than or equal to 3 mu ms. This is the final answer. Okay, I hope you understand. Whenever you have inequality, why I have not substituted Fs equal to mu n? You can't take that unless you know the condition. They're specifically asking you to find the condition it will happen. So you keep Fs as Fs, you solve it, find Fs, and then you equate it to the inequality we have. You substitute in the inequality we have for static friction. So whenever you have a problem with inequality, you have to go and use this idea. So tan theta is less than or equal to 3 mu ss. Okay, this is the condition for which this will have this. Okay, without sliding. Okay, I hope this is clear. If you have any more doubts, you can post on the Telegram channel. If you like the video, hit the like button from everyone. See you. Bye bye.